Hello everyone, this is Mr. Kaviani, and by the end of this video you should be able to explain the relationship between average velocity, average speed, displacement, and time, and calculate the velocity and speed of an object given its initial position, initial time, final position, and final time. Let's begin by defining average speed and average velocity in terms of things that we already know. Now, you may remember from the buggy cart lab, we defined the average speed of an object to be the total distance that it travels, total distance, over the total time that the object has been traveling for. So if you can calculate the distance the object has traveled, again, all of the different steps that object has taken, and then just divide that by the total time that object has been in motion for, you get our average speed. Now, our average velocity is a little bit different. We'll represent average velocity with a V and then a bar over the top. This just means average. So this bar just means average. And our V stands for velocity. Now, our average velocity is similar to speed. That's going to be the total, not distance, but displacement. So not distance, but displacement, total displacement over total time. So the denominator is the same as speed. Our average velocity is our total displacement over our total time. And remember, our displacement, we represented that as delta x. So we can represent that as delta x over t for shorthand. And if we write out delta x as x final, my final position minus my initial position. So wherever I end up minus wherever I began, I divide that by my time, I get my total displacement. And it's important to note that because displacement is a vector, right, meaning it has a magnitude, a number, and a direction, up, down, left, right, north, east, south, west, velocity is also a vector. So let's take a look at an example over here. Let's say on the right, you see this image. You're going from your house to the store, and the store is 3 kilometers away. So you go to the store, and then you come back home. And let's say it takes you 30 minutes to make that trip. So what would your average speed be? Well, to find our average speed, I'll go ahead and put that as average speed. We'll need to calculate the distance that you traveled. Well, if you went 3 kilometers to the store and then 3 kilometers back home, that would be a total of 6 kilometers. So 3 plus 3, that's going to be 6 kilometers total. And we'll divide that by the total time. Again, that's 30 minutes. So that would be 6 kilometers over 30 minutes. That'll give us 0.2 kilometers per minute. So that's our average speed. But how about our average displacement? Well, I'll write out our average velocity. Our average velocity. Gave it away there. How do you calculate average velocity? That's going to be our displacement over our time. Okay. In this case, what is our displacement? Well, I begin at home and I end up back at home. That means the change in my position from beginning to end is 0. I begin and end in the same location. So to calculate my average velocity, that would be 0 displacement over 30 minutes. But 0 divided by anything is just 0. So my average velocity is actually just 0. This is an example where the average speed and average velocity are actually quite different, and that's because we're traveling forward and backwards. If you're just traveling in one direction and you don't change directions at all, your speed and your velocity will essentially be the same because your distance and your displacement are the same. Every second you get further away from your house, and at any moment in time, you are exactly that far away from your house. So speed and velocity are only different when you have an object moving in multiple directions, maybe going forwards and backwards, or traveling from left to right. So this would be an example of how you calculate numerically the average speed and average velocity.